Okay, so I'll choose number 1. What's inside? Right, the electronic configuration for barium. Wait, I had this yesterday. What's the electronic configuration for barium? The electronic configuration. K, L, M, N, O, P, Q are the shells. Now, these shells, they have one or more subshells. These subshells are known as the S, P, D, and F. In the periodic table, we can see that the periodic table is divided into certain blocks. We have the S block, the P block, the D block, and the F block. So these blocks could help us determine which elements are breakdown into the electronic configuration, but we can use it later on. Back to the SPDF, where S starts from the first shell, and P starts from the second shell, and D starts from the third shell, and F starts from the fourth shell. So S starts from the first shell and so on, P starts from the second shell and so on, D starts from the third shell and so on, and F starts from the fourth shell and so on. And then S, it has a maximum number of 2 electrons. P has a maximum number of 6 electrons, while D has a maximum number of 10 electrons, and F has a maximum number of 14 electrons. Here is the mnemonic device of electronic configuration. As we see here, we have all the SPDF and all the shells. Okay, so how to use this mnemonic device of electronic configuration to determine the electronic configuration of an element is actually going diagonal. So we have to first start with the 1s2, and then the 2s2, and then 2p6, and the 3s2, and the 3p6 and the 4s2, then the 3d10, 4p6, and the 5s2, then the 4d10, 5p6 and the 6s2, and then the 4f14, 5d10 and 6p6 and 7s2, and then 5f14, 6d10 and 7p6, and so on. So for example, you want to know the electronic configuration of, say, sodium, which is Na. We first start off with 1s2. Since we know that sodium has 11 electrons, all of these configurations, the number of electrons should actually match with the actual number of electrons of the sodium. So we start with 1s2, 2s2, that makes 4, 2p6, that makes 2 plus 2 plus 6, which is 10, and 3s1. So in the third shell it only has 1 electron. So there you have it, the electronic configuration of the sodium. Now for every element, you use the same way. and every element has its own electronic configuration. Say now we have an electronic configuration here, but we don't know what element does this belongs to. Let's go back to the periodic table. Okay, in this periodic table, there are the blocks. In these blocks, we can determine which one is the element. So let's see here. The last one is 3p5. So it depends on the last one, on the last electronic configuration, which is 3p5. Now let's see in this block periodic table. So it's in the p block. It's in 3p. So we count from 1, 2, 3, 4, 5. So it must be this one. And let's go to the real periodic table, where 1, 2, 3, 4, 5. So the element is chlorine. So this here is an electronic configuration for chlorine. And that's how you figure out the element. Okay, so if barium got 50 electrons, so then it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, and 6s2. Done. That's the answer. Wait, what is this? Where did this come from? Go to the outdoors and face the quantum theory. You mean quantum numbers or something? Okay, so I have to go outdoors.